it takes time to develop an immune response. So during that time, your immune response is not optimal, right? It's not fully mature. That is one thing. The other thing is we are already dealing, before we started the mass vaccination campaign, before they got rolled out properly, we had already variants. So again, the immune response that you are mounting when you have been vaccinated is suboptimal towards a variant that has a spike protein which is different from the spike protein in the vaccine. So the vaccinal antibodies against the spike protein are suboptimal because the S protein of the variant is not the same. So we are, when we are vaccinating people, as I was saying, you are going to war, but your arm isn't charged yet. You are already fully under attack, and you still need to mount this antibody response. And you are attacked by things that you have not learned to properly recognize. So the immune response is suboptimal. So this creates what we call an immune pressure. It's definitely a pressure on the virus. The virus isn't happy with his immune response. But it is going to be able to adapt to that immune pressure. Why am I saying this? I'm saying this because whenever you have to adapt a virus or a microorganism, but I'm talking about viruses, to unfavorable conditions. Let's say you would like to do this in the lab. You have a virus and you would like to adapt the virus to an unfavorable condition. That unfavorable condition could be cultivating, for example, an influenza virus on eggs instead of on a cell culture, or incubating your virus on a temperature that is not ideal for the cells to grow and for the virus to produce. But it could also be, the unfavorable condition could also be an immune pressure, antibodies, for example, that are present. So if you would like to do this in the lab, you would like to adapt a virus to unfavorable conditions. What you would do is you would take that virus and you would put it on a cell line in the presence of those unfavorable conditions. So in this case, it would be a suboptimal antibody dose, let's say. But then that is not sufficient because, of course, you have always, and that is the argument of many people, yeah, you have all the time variants and mutations, etc. Of course. But now you will select certain mutations that are capable of dealing with this unfavorable condition, right? So you will select those variants. But that is not sufficient because it's not because you have done this selection one single time that this variant is now going to become dominant in the population. It will still have a very low, we call this a viral titer, a very low concentration. But now if you take that virus or all these viruses and you're now going to inoculate this on another cell culture under the very same conditions of immune pressure, and then you do it again and again and again, then ultimately this mutant will adapt to these unfavorable conditions and it will have a competitive advantage compared to the original viruses. And that is how, in the course of time, this population of these mutants that originally were only present in very low concentration will now become predominant. So now you extrapolate this to people. What you're going to do in order to be able to adapt a viral mutant, you would need to passage a virus from one person to the other. But in order for that virus to be able to adapt, it would be important that these people are under the same immune pressure, also experiencing a situation of suboptimal immune response. And what I'm saying is that if you're already having variants before you start your vaccination campaign, and then you're immunizing in the heat of the pandemic, where while the immune response is built up, you're already under attack. Many people, of course, in such situation are going to be experiencing a suboptimal immune response. And hence this will enable mutants that occasionally emerge, of course, to adapt and to gain a competitive advantage and to become dominant in that population. And then, of course, we have a problem because this is what we call selective immune escape. You select it and you enable the virus to adapt to that situation so it becomes predominant. And that is what we are seeing right now. As soon as you have an infectious variant popping up, guess what? I mean, it takes like a few weeks or it becomes predominant in the population.